today we will be starting with the lab. So the topic which we will be discussing today is known as your DHCP, which stands for Dynamic Host Configuration Protocol. So see guys, as we have discussed in the IP section, like when we were discussing the IP address. So if you guys remember that I told you that there are two methods through which you can assign the IP. So for example, let me show you. This is my packet tracer, and for example, I have 1, 2, 3, 4, 5, 6. So I have 6 machines, right? So there are two possible solutions, like through which you can assign the IP addresses on these machines, right? The first one was your static, and the next is your DHCP, like automatic IP. Getting guys?
Yes, sir.
So this DHCP, like today we will be discussing this DHCP. What is this DHCP and how does it is going to work in the network? But before that, let's understand some theoretical part. So if you will see, like DHCP is nothing but it is a kind of protocol which allows the server. It allows the server to dynamically obtain the IP address. So for example, if you have this is your router, and this router is connected to your switch. This is your network switch, and your switch is connected to some clients in the network. First client, second client, and third client, right? So you have 3 clients connected. So see, like for example, now in your organization, if you are having more than 100 computers, right? So is it a possible solution that on every of the machine you will be going and assigning the IP address statically?
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
It's not a relevant solution in today's network. So in spite of that, what we do is we simply go and configure DHCP server on this router, so that like this router is automatically going to provide the IP addresses to the clients. So real machine as well. ncpa.cpl. See guys, this is my Wi-Fi network and I'll be going in properties. But before that, let me show you details. See guys, I have some details here. IPv4 default gateway, DHCP server, and IP address. So my machine IP address is 1.39. Okay. Now if you will go in properties and if you will click on IPv4 TCP IP, so you see that obtain IP address automatically, which means I am getting the IP address from the DHCP server. Okay guys, clear?
Yes, sir.
Any queries still here? Now see how we will be doing this DHCP. But before that, see, like as I have written here, allows the server to dynamically obtain the IP address, or like we can say obtain the IP address to the clients. Now how the clients are going to access the IP address, and along with the IP address, like DHCP also provides the IP subnet mask. Guys, so everybody knows now what subnet mask is. Default gateway, and lastly your DNS server. So these are the details which your DHCP server is going to give to your client machine. Now tell me guys, any of the term you are not familiar with IP, subnet, default gateway, DNS?
The default gateway, sir.
Okay. So what is default gateway? See, on every router there is one IP. Like for example, we are connected to this router from this interface to this interface, right? So whatever the IP we will be assigning on this interface of the router will be known as the default gateway. Basically, default gateway is nothing but router's IP, because this router IP is going to act as the entry point as well as the exit point for your network, right? So default gateway is nothing but the entry exit point of your network, and it is also considered as the IP of the router. Okay. Yes, Gopi, Vicky, Malsoor.
Fine, sir.
Okay. See guys, if you have any kind of queries in between, if you are not getting things, so just do prompt me in between, like because I'll be solving out your query at that moment only. So what are the advantages of configuring DHCP? The first advantage is a centralized management, right? That we are able to manage all the devices from a centralized location. Like we don't need to go on every machine and assign the IP addresses, right? Second is we can say easier IP management. And the third one is we can say it supports large number of network. So, and it also reduces the work of network administrator, right? Because like if you are configuring DHCP, so it has reduced the work of network admin, that network admin don't need to go on these single PCs and assign the IP addresses. So how this DHCP server is actually going to work? So see guys, this is basically a client server model. So let me tell you working of DHCP server. So like there are two ports number, server and client. So the server, so see guys, in DHCP you have two port numbers. So 67 is reserved for server and 68 is reserved for your client. So if anybody is going to ask you, like what is the port number for DHCP server? So you are going to tell him that these are the two port numbers, server and client. So 68 is reserved for client and 67 is reserved for the server part. Okay guys?
Okay, sir.
Now see how this DHCP server is going to work. See guys, it follow a process which is known as DORA. So see guys, what is this DORA is? D-O-R-A, DORA. So if you will see, D stands for discover, O stands for offer, R stands for request, A stands for acknowledge. Now let's understand what are these processes and how they are going to work in the DHCP server configurations. So see guys, like for example, let's take a scenario. This is a router. It is connected to a switch and this switch has three client machines. This is PC1, this is PC2, PC3, and you have configured some DHCP of 192.168.1.0. Okay, getting guys?
Yes, sir.
Yes, sir.
Now see, what is the first step? This discover. Because back at the working of backend of DHCP, so there is a process which is known as DORA process. So in this DORA, let's start with this discover message. So this PC1. So whenever like you want to get IP from DHCP server, so we always click on obtain IP address automatically, guys, right?
Sir.
So like once this PC1 is requesting for DHCP server. So on this PC1, you are going to click on obtain IP automatically. So once you have selected the option like obtain the IP automatically, so then this PC is going to send a discover message. Okay, that kind of discover packet in the network. The packet will reach on the switch. As you all know that any packet which reaches on the switch, so switch simply broadcast in the entire network for the first time.
Yes, sir.
So like first of all, the client is going to discover in the network with this address, with this broadcast address. So once the discover request will reach on the switch, so switch will drop that discover request to every PC, 2, 3 and this router as well. Let me show you practically guys. See, now let's take a switch and let's take one router. Guys, you are able to see my packet tracer screen?
Yes, sir.
Okay, perfect. See, I'm connecting all these machines with my switch and switch to router, and I'm going on this router. Now see guys, my router is loading, like as we have discussed the basic part in the last class, like how does this router is going to boot. So now we have to write no here. Now which mode is this guys?
User mode.
Yes, this is the user mode. So we will be writing enable here. Now here we will be writing configure terminal to go in the configuration terminal global mode, like where the configurations we have to do. Now see guys, what I am going to do is I want to select the port number, like this router is having this port GIG 000. So interface GIG 0/0/0. Now I am in configure interface, which means I am in the interface now. So I am simply going to turn this port up. As you can see, it's in the red color. So I will be writing the command no shutdown. Now see guys, my port is up and exit. I am out of the mode. Now see what I have done is, now let me show you. Now go on this PC0 IP configuration DHCP guys. See, I have selected DHCP, so the packet is being generated. So if you will click on this message, so see guys, in this layer 7 the packet is 0.0.0 and client is 0.0.0 because it does not have any kind of IP address right now. Getting guys?
Yes, sir.
And see, if you will see in the layer 3 like IP address part, so you will find that the destination IP is this global broadcast address which I have written there in the slide, right? 255, 255, 255, 255. So this PC is going to, like whenever the communication is going to happen in the network. So there are two things to make the communication, the source IP and the destination IP, right?
Yes, sir.
But as of now, in our situation, we don't have the source IP, nor we don't have the destination IP. So in case of destination IP, whenever we are requesting for DHCP, so the first request which stands for your discover is always sent through this broadcast address. Getting, guys? Clear? Yes, guys.
Yes, sir.
Now see, as it was a broadcast request, so now this PC will send this message to the switch, right? And switch will send the request to all of the machines. Let's see. See, the message went on switch, and now the switch will broadcast in the entire network. See, DHCP, it was written, but see, every of the machine has rejected, router has also rejected the message, right?
Yes, sir.
Now, why everyone rejected those message? The reason is because these client machines do not understand the discover message. Only the router is going to understand the discover message. But in our scenario, the router has also rejected the discover message, right?
Yes, sir.
See, it is showing DHCP failed, APIPA is being used, because I told you that when DHCP has a failure, so you will be getting APIPA range, right?
Yes, sir.
So now this was the discover. So let's understand the process. Then I will be letting you know the real life scenario, like while showing you the simulation. So once for the first time, this router is going to discover for the DHCP server that this PC is going to search for the DHCP server through a discover message that is there any DHCP in the network or not. Once this PC finds out that this router has configured DHCP server, so now as you know that in our scenario, one PC1 send the discover request on the network, so everyone rejected, right? Like this. Router also rejected, but if DHCP was there, so router will understand the discover message. Getting, guys?
Yes, sir.
So, for example, now we are discussing this DORA. So, discover means simply, guys, the PC is going to send a discover request, and the discover request is gonna be broadcasted in the entire network through this broadcast address, and the DHCP server is going to understand that I have received a discovery request. Now, in the next offer request, the DHCP server is going to offer some IP address to that particular client. So that, for example, it has offered some 192.168.1.1 or any IP. So then the client will request, yes, I am ready to accept this IP. So will you please send me this IP? So the router will send that IP. And in the last acknowledge step, the PC is going to acknowledge that I have yes taken this IP address. Okay, guys.
Yes, sir.
So this is what the entire DORA process is. So before this is what works at the back end of your DHCP server whenever you are configuring your DHCP server. Is this clear now?
Sir, here when PC1 sends a request to switch will do flooding or broadcasting.
See, switch will firstly broadcast in the network. See, this was your router, which is connected to a switch. Now, and this switch is connected to 3 computers. See, PC1, 2, 3. This is the scenario which we do have in the packet tracer as well. See, now let me show you one more time. Just focus on the simulation part now. I'm going on this PC0, IP configurations, DHCP. Just a second, guys. Let's go on this PC, desktop IP, DHCP. See now, the type is DHCP message. Here you can see, right?
Yes,
The
sir.
message which it has created. So see in the OSI layer 7, like it is showing me server ID, client ID 0.0.0. If you will see in the layer 3 address, guys. So in layer 3, what as we have discussed in the OSI model, that layer 3 consists of packet, source IP, destination IP, right?
Yes, sir.
So you will see that source IP is what?
0.
0.0.0,
Yes, sir.
because this machine has no IP address.
Yes, sir.
But the destination IP is what? The global address, global broadcast address.
Yes, sir.
So discover message is always going to be broadcasted in the network. Now see, once we will send the traffic, now this PC is going to request for the DHCP. So see, it will reach on the switch and switch will broadcast in the network again. See, it has broadcasted. Everyone is going to reject because no DHCP has been configured, right?
Yes, sir.
But if you have configured DHCP server in your network and this client machines are requesting for discover request, so DHCP is going to understand the discovery request because it's a part of discover for request acknowledge is a part of your DHCP server, right?
Yes, sir.
So now as you can see, it is also getting a pipa because no DHCP has been configured, right?
Yes, sir.
So how we will do? Yes.
Switch will do flooding or broadcast, sir.
Yes, switch is going to broadcast for the first time. It is not going to flood in the network.
Okay, okay. So, I know difference between flooding and broadcast.
See, basically they are pretty much similar, but like see, flooding is somewhat, the forwarding of the traffic in between the network, like whenever we are forwarding the traffic.
Okay.
So this is what the basic difference. So can we move on the, lab part, like how we are.
Sir, I have a question.
Mhm.
Sir, from client side, what type of packet are sent?
From client side?
Yeah.
See, client is going to see, we have discussed the DORA process. Let me write it down once again. Discover, offer, request, acknowledge, right?
Yes, sir.
Discover is always done by the client, offer is done by the server, request is done by the client, and acknowledge is done by the server. Because client is going to discover for the DHCP server and DHCP server is going to offer the IP server.
Yes, sir.
Then client is going to request for the IP, right? That I
Yeah.
want this IP and server is going to acknowledge that you can take this IP now.
Yes, sir.
So this is what the process of your DHCP is. Okay.
Okay, sir.
So now how we will be doing that? See, we'll be going in this router. Now, first of all, guys, what you need to keep in mind, like whenever you are configuring the DHCP server, the first thing is that you must be like creating a default gateway. Basically, see, now on our router, through which port we are connected to the network? This gig 000.
LAN interface.
Yeah, through this LAN interface, this is gonna be a default gateway. Like it is going to act as the default gateway in your network. So for example, I will be assigning the default gateway as 192.168.1.100/24, which means 3 times 255.0.0. Now I'll be going on this router and let's start the configuration of DHCP. So you will be going in the global configuration mode, guys, and then you will be writing the first command, which is service DHCP, which basically means, guys, this command we sometimes, like it is not important to write this command, but in some of the cases you will find that you have done the various configurations in the DHCP server, but still your DHCP server is not working. So this command is basically used to enable the DHCP server, but sometimes if you will not be writing, so it is okay, you like, but in like 99% it's okay, like you can go without this command, but in 1% of scenario you will face challenge like this, it is not working, so you do have to enable the DHCP by writing this command. Okay, make sense?
Okay.
Now see how we are going to configure the DHCP server. So the first command is IP DHCP pool, and pool you are going to assign as any name you can assign for that pool. Now see what does this command means, IP DHCP pool. So like like in one octet of IP, like you can assign 254 addresses, right? Yes, guys.
Yes, sir.
Yes, sir.
So we have assigned the pool, like all these addresses we will be putting in this pool. So the next command is you have to assign the network now. Network. The network is 192.168.1.0. The subnet for default network C class is 255.255.0, right? Now you have to assign the default gateway, default hyphen gateway. Sorry, it's not default gateway, it's default router. Now 192.168.1.100. Okay, guys,
Yes, sir.
this is your default router. if you want to assign DNS server, so let's say 8.8.8, I am assigning the DNS server, or else it's your choice. You can assign any kind of server address, right? This is what we have done the DHCP configurations. Now let me show you exit. Now see guys, on which mode we are? On the privilege mode. Where do we troubleshoot? So if you will write show IP DHCP pool, so you will see that the pool we have created is Cisco, right?
Yes, sir.
And utilization of 100 to 0. Total addresses are there 254. What is the first network? 190. Like this is the network 1.0. The IP address range is from 1.1 to 254, right?
Yes, sir.
Yes.
Now let me show you one more command. Show IP DHCP bindings. Now see guys, now in this command show IP DHCP binding, what do we verify is, so see guys, as of now no binding is there. It's showing blank. Now see, I will be going on my machines. Let's verify on simulation. Now see guys, previously when we were, checking the requesting for the DHCP server, so every machine was rejecting, right? Router was also rejecting the discover message, right?
Yes, sir.
Now if you will see, client machines are going to reject because they do not understand that discover message, but router is going to accept now. See, everybody rejected. Still, okay, router has also rejected, guys. Just give me a second because I have not assigned the IP address. See, guys, apart from that configurations, as I have configured, let me show you. I have written this command default router, right? 1.100. But I have not assigned this interface the IP address of 1.100. So I need to assign the address of this interface. So that address will be configured. I will be going on again configure terminal interface gig 0/0/0 and IP address. This is how we assign the IP on router and switches. So IP address you will be writing 192.168.1.100 is the IP and the subnet mask 255.255.0. Enter and no shutdown. Now see guys, I have also assigned the IP address. Now let's go in the simulation. See guys, now the router is going to accept our DHCP discover request. See, one packet was generated, it has accepted. See, and it has sent back the machine packet, right? But let's close this simulation now and see. It has get the IP of 192.168.1.2 DHCP request successful. If you'll be going on this PC0 IP configurations, it is still showing a PIPA, right? But
Yes,
if you
sir.
will refresh it, it has get the IP of 1.3 from the network 1.0, right? Default gateway we have assigned is 1.100. Subnet mask is assigned. IP is also there and DNS is also there. Clear, guys?
Yes, sir.
So this
Yes,
is
sir.
how you will be configuring your DHCP server. See, we got 1.4 here, 1.6 here. Okay, clear, guys? Do you want me to write the commands for you?
Yes, sir. Yes, sir.
See, guys, these are the commands which we have written: service DHCP, IP DHCP pool Cisco, then the network we have assigned, the router we have assigned, and the DNS server we have assigned. These are the commands to configure the DHCP server. And apart from that, what we have done is we have simply selected the interface and we have applied the IP address on this interface. See, these are the three commands which we have given on the interface, right? Make sense now?
Yes, sir.
Now see guys, I showed you one more command. See, if I want to go on the privilege mode, I do right to exit 2 times, right? But if you will press Control and Z together, so you will redirect it to, on the privilege mode. So see guys, show IP DHCP binding was the command I showed you. So now from here you can verify. See, these are the IP addresses which has been allocated to the client machines. So if you will see that 1.5, so let's copy the MAC address of this 1.5, copy, and let's check which machine is having 1.5. It's having 1.2, it's having 1.4, it would be having 1.3, This machine is having 1.5 IP address, right guys? PC1.
Yes, sir.
So now let's check on the router again. 1.5. I am copying the MAC address of this PC 1.5 machine. So this machine is having 1.5. So if you will paste the MAC address here. Now see guys, I will be verifying you the MAC address as well. IP config #all. Now see guys, the physical address, if you will be checking, it's FE80. You can wait a second. Yeah, sorry, it's the IPv6 address, guys. This is the MAC address, this physical address. So 000C CFED ABE0. It's written here as well. You can see, guys. You can verify. So by the binding command, you can verify that which machine is having which particular IP. So in the advantage of DHCP, like I mentioned here, if you guys remember the point, that centralized management and easier IP management. So now you are able to identify that which machine is having which kind of IP, which particular IP, right?
Yes,
Yes,
sir.
sir.
So this is how you will be, verifying the DHCP server. So guys, I think like you all have installed packet tracer in your machines.
Yes, sir.
Yes, sir.
Okay, so now I'm, like stopping my screen, and Gopi, you are going to share your screen and then just perform a quick lab. Rest, like guys, you also have to perform the DHCP lab. Then we will be moving on the next part. So just write the command show IP DHCP plotting DHCP. Yeah.
Actually,
So
I have it. MAC address.
yes, these are all the MAC addresses and these are all the IP addresses which you have assigned on the machine. So I hope the concept is clear to everyone now. Vicky, Tarun, Malsoor.
Yes, sir.
Okay, guys. So see, we do have one more concept in DHCP. Now let me share my screen and let me tell you guys what is that concept. See, guys, there are two types of server deployment model in case of your DHCP. Let's put this aside. Let's take some computers. One, two, and let's take one router again. And let's take one switch. Now see guys, if I tell you like you have to create two DHCP server in your network. For example, your organization is having two routers, right? Like this. Okay guys. So for example, like it might be possible that there are two routers in your organization, or there might be 3, 4, 5 routers in your organization. This is a possible scenario because it is not possible that in your organization where you will be working, there would be only one router. There would be more than one, or maybe two, three, like that. Like there can be any routers, right? Many routers there could be.
Yes, sir.
So what's the scenario with this? Like there are two types of server deployment model in case of your DHCP. Let me write it down here. Two types of DHCP server deployments. The first is centralized and the second is decentralized. So what's the difference between centralized and decentralized is, for example, let's get back on the topology. See, now we have two routers. This was router 1 and this is your router 2. And we have configured DHCP server on only router, like on this router only, right? We have not configured DHCP on this router. So let's say, if I ask you, Vicky, that Vicky and Tarun, that if I want to configure two DHCP servers in my two routers, so how I'm going to do that? What will be your answers, guys?
In second router, we will create another set.
Other DHCP pool, like the commands will be same, service DHCP pool name we will be changing, and network we will be changing, like 1.0. Like in spite of using 1.0, we will be using 2.0, right?
Yes, sir. 2.1 and 2.2 will be assigned to PC.
These IPs will be assigned to the PCs. But for that, you have to go on the router 2 and then configure the DHCP server, right?
Yes, sir.
But see, like there are two types of deployment models in your DHCP server. The first is your centralized and the next is your decentralized. Just a second. So what does the centralized model says? That single DHCP for all routers and separate DHCPs on every router. Now, as per our scenario, like as Gopi was saying that we will be configuring these commands on this router, right, Gopi?
Yes, sir.
So that will be the decentralized model. Like how many routers, for example, if you have 3 routers, so you will be going on different routers and then you will be configuring the DHCP server, right?
Yes, sir.
But before that, before moving on that part, let me show you that what is the centralized model of DHCP says. Like in case of centralized model, you can configure a single router with multiple DHCP pools. Like you don't need to configure this router as DHCP server. In spite of that, what you will be doing, you will be creating the DHCP pool on this router for this network. How we will be going to do that? Let's go on this router, enable, configure terminal, IP DHCP pool. I'm writing PyNet. Now network will be 192.168.1 sorry 2.0, 255, 255, 255.0. See guys, I have configured the 2.0 network. In default router, I will be assigning 192.168.2.100 and DNS I will be assigning as 1.1.1. Okay guys, these are the commands which we do to configure DHCP, right?
So
Now
DNS can be same or different, sir?
it depends, like we are using the packet tracer, so it's optional, like you can use any value, but in real life scenarios you do need to check like which server your company is connected to, and like you will be assigning that same DNS server.
Okay, sir.
Yeah. So now see guys, now as I have configured the pool for another router on this router as well. So see, show IP DHCP pool if you will be checking. So there are 2 pools now. The first pool was the name of Cisco, which was having the IP address of 1.1 to 254. And the next pool we have created is PyNet, which is for the next router 2.1 from 2.1 to 254, right?
Yes,
But
sir.
see guys, as of now, my ports are in the shutdown state. Like I do need to manually up the port and assign some IP addresses to make the communication possible. Because once this PC is going to request for the discover message. For example, let's say this is the discover message. This discover message will reach to this switch and this switch will pass to the router, and then this router will forward the traffic to this router, right?
Yes, sir.
But to make the communication possible between 2 different networks, we always do need a router, and routing configured should be there, right?
Yes, sir.
So I will be doing a little static routing here to make the communication possible between different networks. So let's say, for example, I will be taking the gateways 192.168.2.100/24. So I'll be going on this router gig 000. Like see guys, interface gig 000. No. Enable, configure terminal, interface gig 0/0/0, IP address 192.168.2.100, no shutdown. See guys, as I have assigned the IP addresses on this interface, like default gateway I have assigned. So now my port is in the upstate, right?
Yes,
So
sir.
if I want to make the communication between these 2 routes, so I do need to assign 2 IPs on these interfaces as well. So let's take some class A IP address. 10.0.0.1 I will be using here, and 10.0.0.0.2 I will be using here. And it's optional, like guys, you can use any IP if you want to use. Okay. So let's go on this router again, configure terminal, and I will be changing the host name so that there would be no confusion. Host name R1. Now this is your R1, and on this R1 interface gig 0/0/1, IP address 192.160 sorry 10.0.0.1, by default A class subnet mask, right? No shutdown. Now I will be doing on this router too. Let's change the host name to R2. This is your router 2. So now there will be no confusion. Interface GIG 0/0/1, IP address 10.0.0.2, 255.0.0, and no shutdown. Now my entire topology is up, guys. Every port is in the up state.
Yes, sir.
Till here, any kind of doubt, so you can ask me now. I have done nothing. First thing I have done is I have created a pool for 2.0 on this R1, and then we have assigned some IP addresses on this router and on this interface. That's it we have done. Okay. Now you all know that, like, whenever we want to make, yes,
Sir,
yes,
we
yes,
have to
Gopi.
create IP address on both routers, sir, gateway.
Yes, right. Because see, this
Right.
there should be one entry exit point for your network now. So like if there is no entry exit point, so how your packet is going to get out of the network or get inside the network? Because like whenever we make the communication over the internet, so there should be two things like the source and destination. So here also you do need to assign the source IPs and destination IPs, right?
Okay, sir. Like both side we have to create, sir, IP address gateway.
Yes, both sides, but it's mandatory because if you are not assign the IP address, then how you will be communicating? For example, if you don't have my mobile number and I told you that please Malsur call me on my mobile. So how you are going to call me if you don't have my mobile number, right?
Okay.
So IP is somewhat the identity of all these devices through which you are able to make the communication between each other. So that's why IP address is quite mandatory.
Sir, after creating gateway IP address, you have returned 10.0.0.1. You have returned, no, sir.
Yes,
I,
here, this
I,
IPs.
sir, already created you IP address on router, no, sir.
See, these are the IP addresses which I have written because see, I have made the communication between this R1 and R2 through this cable
You
using
created
this.
all, no, sir. 192.168. Like per
This
router.
is on this. See, this router is having two ports. This port number 1 and port number 2. So on every port, like on every interface, I do need to assign the IP because right now in my scenario, I am making the communication possible from this one dot network to two dot network. So there should be one IP in between which is going to make the communication, right? See, let me show you.
So we
I'll
have
be
to
yes.
so we have
Say
to give two IP addresses, no, sir.
yes, right.
Per
See, let me show you. We'll be going on the R1. If you will write show, see guys, show IP
Sir,
interface. Yes,
I have to confirm one more doubt, sir.
yes, say.
Port address means it's an application address, no, sir.
Which means what?
Port means it's an application address, no, sir.
Application. No, it's not an application address. It's basically, port is somewhat. Let me show you. See, this is the command show IP interface brief. Now see, there are ports on the network devices like switch, routers, right? So if you will be writing show IP interface brief here, and if you'll press enter, so you will see that your router is having the port like three ports, gig 000, gig 001, gig 002. Let me show you these ports. In physical, you will be going, if you will click on zoom in, so you will see that there are 1, 2, 3, 4, 5, 6. These ports are there. So 1, 2, 3. These three ports are there on this router. But in real life, you will be configuring these ports using the CLI mode like this. So as you can see on this gig 00, which is connected towards the LAN interface. So you have assigned the port number like this IP of 1.100 to this port, and 001 port have been assigned with 10.0.0.1. Because see, let me explain you one more time on the PowerPoint. See, whenever like this PC is making the communication, this PC wants to communicate with this PC. So the packet will go like this. It will first go on the switch, then switch will send to this router, and the router will send the packet like this from this route. So there is a one route in between the two networks, like in between 1.100 and between 2.100 there is a route now. So like we have used these addresses to make the communication possible between two different networks. So like whenever you are using any router interface, so it is always mandatory that you must be assigning IP address. Okay.
Yes, sir.
Sir,
Yes.
For PC0 to router 1, we have to assign one more IP, no sir.
Where
router?
on PC? On router 2?
Router, not sir. Router 1 to PC0, we have to assign one more IP, no sir, to communicate.
Yes, so we have already assigned this IP.
Yes, sir. Yes, sir.
Yeah, and here we have assigned this IP because these IPs are going to act as your default gateways. Because whenever the packet will go outside the network, so it will directly go from this IP, right? So this is actually going to act as the entry or exit point of your network, right?
So we can
Okay.
use any class IP address.
It's up to you. But see, it like in packet tracer, just to perform your collapse, you can use any IP. But in real environments, you have to check like which requirement is there and what your company is going to say, like which IP you are going to use. Okay.
Okay, sir.
Yes, Vicky.
Yes, sir. I got it.
Okay. Any other queries, guys? Tarun, Malsoor.
No, sir.
Okay. Yes, Tarun. Gopi.
No, sir.
Okay. So now see, like what we have done previously is we have assigned the IP addresses and we have assigned the pool of router 2 on this router. But see guys, if you will be requesting here from PC6, now we have assigned the IP addresses and also we have created the pool. If we will be requesting DHCP server, so what do you think guys? Will be getting the IPs or not?
Will get, sir.
See, let's try now. See, DHCP failed because we have not we have not done the routing. So if you will check the communication from this PC to this, from this, let's go on this router first on R1. And if you will check the communication ping 110.0.0.0.2. So it is not communicate. See guys, it is communicating 80%. We got the rate. Let me show you one more time. We got the success rate as 100%, like we are able to ping with 10.0.0.2 from R1, right? Which means the communication is possible from here to here, right?
Yes,
Getting
sir.
guys?
Router to router.
Router to router communication is possible. But let's try to ping 192.168.2.100. So are we able to ping with 2 dot network or not? Let's see. See, we are not able to make the communication because both of the IPs are from different class A and C, right?
Yes, sir.
As well as we have not done any kind of routing. So, whenever we will be doing this part, like I will explain you this in more detail when we start the routing. But before that, you do need to understand little basics of routing. So routing is somewhat whenever we are trying to make the communication possible between two different networks. Like if I want to make the communication between 1.100 and 2.100, so I will use routing here to make the communication. So how we will be doing that routing? You will be going on R1 and you will be assigning the root. So configure terminal you will be writing first, going on the global configuration mode. Now IP root 192.168.2.0 network 255 255 255.0 and 10.0.0.2. This is the command. See guys, IP root 192.168.2.0, which means you are making a route for 2.0, which is the destination. This is the destination subnet mask, and this is the next router ID, because whatever the packet will go from this router, so it will redirect it to go on this port, right? On this 10.0.0.2, right? Then it will enter in this particular, in your machine, right? Getting guys?
Explain once again, sir.
Okay, see. I have written a command IP root 192.168.2.0. Right now I am on R1, as you can see. So
Yes, sir.
I am assigning a root, like I am doing routing here. Routing is somewhat, if you will see that this is packet, like this packet from this machine, it will go to this router if it wants to go on the next router. So it will go like this, right?
Yes, sir.
So first of all, it will go on which port first? It will go on 10.0.0.2.
Yes, sir.
On this interface, it is going to reach on first na gig 001, right?
Yes, sir.
Then it will enter in this gig 000, right?
Yes, sir.
So that is what I have written on R1. I have assigned a route like IP route. This is my destination that I want to reach in this destination 2.0 network, the default subnet for 2.0. And this is the next hop IP. Like from this address, I will be entering inside 2.0. Okay.
Okay, okay, sir.
Now the same we have to do on R2. So enable configure terminal IP route, and I want to assign the destination for 192.168 1.0 network, right? Default subnet will be this, and it will go in like
Ten
you know
dot
it will,
zero dot 0.1.
yes, right, 10.0.0.1. Now if you will verify this part, that are the routes there in your routing table. So the command is show IP route. See guys, we have configured a static route here. It is showing 1.0 and 2.0 in this in its tuple in its routing table, and this C and L is the like connected route which is already there and locally connected like it's 10.2, and one more local connected route is 2 or 2.100 which is already there on this router, right?
Yes, sir.
Now what is the additional route you have added? You have added static route for 1.0, which means now see previously when we checked the communication with 2.100, we got the success rate as 0%. But if you will ping now, got the success rate as 100% with 2.100. Now your 1.100 machine is able to come like this 1.100 network is able to communicate with 2.100. So now we will be getting the IP or not from DHCP, because now the communication is possible between two different networks, right?
Yes, sir.
So let's see IP again DHCP I'm requesting. See, still we not get the IP, right?
Yes, sir.
So now why we didn't get the IP address? Because there comes a concept of DHCP frame relay. Sorry, DHCP relay agent. So in that scenario, what we have to do is now you have to configure this R2 as a relay agent. Relay agent is nothing but it is going to, send the broadcast request to this router. So for that, you don't have to do nothing. You simply have to go on this router one, and you will be going on the configure terminal, and you will be selecting this interface port, like interface LAN interface you are going to select, which is gig 0/0/0, and you will be writing the command IP helper address 10.0.0.1, which means now you have configured this router as a DHCP relay agent. So relay agent is nothing but a kind of DHCP router which is going to act in between both of the routers. Now this, like, see, for example, what was the previous scenario? This for example, this was the discover message 2.100. So if it will was reaching on this switch and switch was proceeding that message to this port gig 00, right? But this gig 00 was not forwarding this message to the another route. So that is why we have created a DHCP relay agent. So from that relay agent, we will be getting the IP from that router only now. See guys, we got the IP 2.1 and 2.100 is the gateway. As we have configured the DHCP on R1 only, we have not configured any DHCP on R2. So if you will check in R1 now, show IP DHCP binding. So you will see that 2.1 binding address is also there in the DHCP pool. Okay, guys.
Okay, sir.
So this is how the work of deployment model of the DHCP is going to work in the entire scenario.